And we did the choose and the check. Yes. Okay, so then on the calculate, remember you want to do the test statistic is equal to the statistic minus the parameter. That was really loud. Okay, divided by the standard deviation. You want to say the general formula, and then you want to get specific. Okay, so then we're going to say P1 hat minus P2 hat minus P1 minus P2 over the square root of the combined P minus the combined P divided by N1 plus combined P times 1 minus, come on, little thing, combined P divided by N2. Now, the combination of these two things, you have how many children in total? 180. So high. Okay, so out of the 180, how many had a stuffed animal? There, sorry, how many had better sleep because of the stuffed animal? 34. How many had better sleep because of the blanket? 60, right? So that's going to be 34 plus 60 divided by 180. That's going to be 0.52. Remember, there was only 80 children. 75% of 80 children is going to give us 60. What's up? 75% of 80 children. So 80 times 0.75. Yeah. Okay. So now you're going to plug in. Whole hot mess. Okay. When you plug in, you should have gotten negative 0.41 minus 0 divided by the square root 0.52 times 0.48 divided by your N1, which was 100, plus 0.52 times 0.48. This is real messy. Divided by 80. You're going to plug. Again. Okay. Go ahead and plug that into your calculator, and then what do you get? Say again. Okay, negative 5.47. Okay, if we go to our table, are we going to find negative 5.47? No. So what is the p-value going to be? 0. The p-value is going to be 0. Okay? Remember, you got to draw your little normal curve, right? And it can be a rough sketch. Your middle is 0. Where you're looking for is negative 0.41 and below. Okay? Do you lock it back? Yeah, just put them up there. Thanks, babe.
I think that's all of them.
Thank you.
No problem.
Okay. Thanks, you too. All right, so everybody's good on that. Now we've got to do the conclusion. All right, so conclusion, you are going to interpret your p-value, and then you're going to state your decision, okay? Why is what? Because remember, find the difference, the parameter is 0. So our null hypothesis is kind of like our middle. Yes? Good so far? Okay, in conclusion. No. Okay, in conclusion. We're going to assume the null hypothesis is true, which is P1 minus P2 equals 0. Okay, there is about 0 probability of getting okay, of getting negative 0.41 or lower purely by chance. Okay, and because 0 is less than 0.01, do we reject or do we fail to reject? We reject. He doesn't make enough money, right? Okay, so we reject the null. And do we have convincing evidence or no? All right, we do have convincing evidence. Convincing evidence that the proportion of children with improved sleep, and I'll pull down the screen in just a second, with a stuffed animal is less than a blanket for all children like this one in the study. Which I think is really funny because the 7-year-old and the 4-year-old have Minnie and Bunny that they sleep with every night. But they actually sleep better when they don't have their stuffed animal.
Who's the 7-year-old?
Evie and Andy, my stepkids. Yeah. Have y'all not seen pictures? Oh.
You're going like
Okay. Okay. I'm like a blank wall.
like Kansas.
For a clear slate.
Yeah. Like I keep saying that you're married and that was.
Okay, I'm not married. I just got engaged like a week or 2 ago.
Okay, so
Yeah. No, I didn't. I did. I'm sorry. It's not that they you. I just feel like when teachers like tell their personal lives, like sometimes kids are like, I don't care. Which is fine, fair. Oh, okay. Yeah. Do what? Oh, okay. Oh, it was great. It was awesome.
Rockford, and then it's like 6 people.
Oh.
Okay. The Wolverine Worldwide, a shoe company in Rockford, Michigan, improperly disposed of chemicals which have leaked into the groundwater. I don't know why I'm laughing. This is not funny. The state of Michigan says that if more than 7% of the households in the city exceeded the safe limit, the city needs to switch to bottled water. This actually, Rockdale, like the whole gas leak and everything. Well, this is Rockford, Michigan, but I'm talking about Rockdale County. You know, the whole gas like explosion fire thing. It's still going on. When you drive through Rockdale County, they go into like a shelter in place from 7 p.m. to 7 a.m. What do you think that they're doing during the night? They're burning off the rest of that stuff. Y'all got dead quiet. Yeah, exactly. That's how I felt. I was like, they doing some sketchy stuff because why are you sheltering in place at night? Don't like it. Okay. Because you can't see clouds at night. Yeah. I mean, you can if it's like super moony outside. First of all, no. Okay, so let's get back to this. This is the important stuff. This is always an FRQ. Always, this topic is an FRQ. There's some question about this. It's a thing. Okay. All right. So fill in each section with a smiley face for a correct decision, bad face, sad face for an incorrect decision. So if the null hypothesis is true, then we reject the null, right? Okay, we reject them if the null hypothesis is true, right? That means that it's less than 0.05, right? Cool. If the alternative is true, we still reject the null. Yes. Okay. If the null hypothesis is true, we can fail to reject the null. And if the alternative is true, then we fail to reject the null. Let me clarify. This is a type 2 error. We're talking about errors. Say again. What? We're getting there. Just write it down. Write down smiley faces. Okay. This one, we got type 1 error. Type 1 and type 2. No, you cannot relate this back to diabetes. Oh, I totally messed this up. Why didn't y'all correct me? Why didn't you correct me? Why did you not correct me? That's a frowny face. These are smiley faces, and this is a frowny face.
Oh, that's so funny. Oh my God.
Stop. That's so bad.
Number one.
Right. So we've got type 1 error and we got type 2 error. Okay. I'm going to explain those on the back in just a second. For type 1 error, okay, the null hypothesis is true, but we find convincing evidence for the alternative hypothesis. So for type 1 error, need you to listen, ready? The null hypothesis is true, but we find evidence for the alternative hypothesis. Does that make sense? Null hypothesis is true. We've gone through, null hypothesis is true, but we have convincing evidence that the alternative is also true. Okay, I'm gonna show you in just a second.
Oh, yeah.
Type 2 is that the alternative is true and we fail to reject the null. Then that means that the alternative hypothesis is true, but we don't find convincing evidence for the alternative hypothesis. I know that's a lot. Okay, let's go through it. So a concerned citizen takes this random sample of 100 households in Rockford and finds that 12 have unsafe water. Does this result give convincing statistical evidence that Rockford should switch to bottled water? I feel like if there's a question, then they probably should, but that's fine. All right, so if the water is safe, these are stating the hypothesis. If the water is safe, then that means that the null hypothesis is P equals 0.07. Because what they stated up at the top was that it was 7%, right? Okay. If the water is unsafe, it said that it's more than 7%, right? So the alternative is that the null hypothesis, P value is greater than 0.07. Remember, when we write the null hypothesis, it's going to be a number. P equals some number. Okay, the alternative is either going to be greater than, less than, or not equal to.
Right.
Okay, what does P actually stand for? The true proportion of all Rockford homes with unsafe water. Can't even drink the water, yo. Nova, you good, homie? That was hot stuff. All right, so after conducting a significance test, a p-value of 0.025 is found. Interpret this value. Okay, so that means assuming that the null is true, that means that p is 0.07. There is a 0.025 probability of getting p hat of 0.12 or greater purely by chance. Where did the 0.12 come from? Because look back up here, it said out of the 100 households that they looked at, 12 have unsafe water, right? They're giving you the information. Normally you would run this test, huh? Because the alternative is greater. Yeah. All right, we okay on this? Okay, are we going to reject or fail to reject? Okay. So because 0.025 is less than 0.05, we reject the null, right? So should Rockford switch to bottled water or not? Why?
Yeah.
Should Rockford switch to bottled water or not? Why'd you say yes?
What she said.
Wait, what?
Why? So we rejected the null, okay?
Is that the water is sick, as you can see. And since the 0.25 is less than 0.0, wait, pause. 0.25 is less than 0.05, that gives us evidence of that.
Wait, hold on. But if the 0.05 is less than 0.5, isn't that also the probability in which, like, that's the probability in which we're getting 0.12 of it?
Right.
Right. But then, if the probability of something greater than 0.025, then how is that also equate to guaranteeing that we're unsafe water with the 0.7?
So you want to take the chance of if it's greater than 0.07, and we just said that there is a 2.5% probability that you could get 0.12 or greater. Now remember, if it's more than 0.07, it's unsafe. So we don't have the 0.07 to 0.12 range.
That's likely to happen in general. This is unlikely to happen if the water is actually safe. If the water is actually safe, we cannot be getting 0.12 or greater of the population having unsafe water. And because it's very unlikely for that to happen, it's most likely that the water is not safe.
Because out of your 100 households, you have 12 people that have unsafe water. You're killing 12 families, potentially.
Then again, if we have 100 households,
If we identify this greater, because that's a sample, the true population is greater than 100. And even then, you are still
and how
like
do we
12
know
families.
if the true population, like, what if they were just in an area with more unsafe water than the rest of the population in the town?
Then it's safer to say, hey, everybody switch to bottled water.
Like, it honestly could be that other places have even more households with unsafe water, and we're just testing on this one.
Also, when you go in and you test the water, what's to say that you didn't come back and it's now contaminated?
And then also the water is shared by the population. So it's going to eventually.
It's eventually going to distribute. Yeah. What's up?
The answer is reject the null and get the water.
Right, wait. Shh. Say it again.
So
that's the alpha that they're giving us. We're going to talk about what alpha to use a little bit later. But for right now, that's the designated one they gave us. Sometimes they'll say 0.01. All right. Shh. I can hear Rebecca. Shh. All right, say it again. Mm-hmm. So if it's less than 0.05 or it's less than 0.01, depending on what your alpha is, then you're going to reject it. Yeah. If it's greater than, then you fail to reject. Yeah.
What we're finding is the likelihood of it happening if the null hypothesis is true. The water is proven safe, why do that people actually have unsafe water?
Then why do you have 0.025 getting unsafe water?
Okay, so if we get so if we're given a question, NRP is like, if NRP follows the HA,
Mhm.
then we just, then, well, one, after we finish it, we're gonna reject it, so, and then the other for the HA is like it's. Like,
Mhm.
okay.
Okay, so let's suppose this decision was incorrect. Let's say, hey, Rockford is actually really fine. They didn't have to switch to bottled water. What would be the consequence of this error?
Plastic.
Oh, so I spend a lot of money.
Bro, you'd spend a ton of money. So Rockford would spend a ton of money, right? Also at whose expense? You know,
And people.
the people, which then, I mean, like, I don't know how long that would go on for. Somebody would probably start trying to sue the company, right? The Wolverine Worldwide. It is a shoe company.
Why does the shoe company have water? Wait.
No, they have chemicals that, bruh. Okay, so if the water is safe, what is the probability that this error will occur? If the water is safe, what is the probability that this error will occur?
No, like, no, I would. How would we get it?
Well, it is 0.05 to 5%. Okay, so 5% is the probability of type 1 error. Okay, so with type 1 error, I'll put this in a different color. The null hypothesis is true, and we reject the null. Cool. So this comes from the alpha. Yeah, that 5% comes from the alpha. Okay, so if it was 0.01 for your alpha, then there's a 1% chance that you got that type of error, right? Type 1 error. Okay, suppose, this is where it starts getting a little weird. So suppose a different sample yielded a p-value of 0.217. Do you reject or fail to reject the null? Okay, so 0.217 is greater than 0.05. So we fail to reject the null. Do you keep the current water or do you do water bottles? Keep the current water. Why? It's greater than 0.05, but like why does that make sense? So the null hypothesis is that the water is safe, right? So we fail to reject the null. So that means that we're assuming that the water is safe, right? Yes? Okay. Now, let's suppose this decision is incorrect. What would be the consequence of this error? Somebody dies, right? So, like, this is risky. So people are drinking, unsafe water. Isn't that still going on? Flint?
Yeah.
It's still happening. That was like years ago. So, yeah. They had undrinkable water for like years. I don't know. I don't know though.
Was it because they put lead in the water and they have like
It's a lead piping because it was like real expensive to like fix. Like it wasn't like a quick solution. Yeah. So type 2 error. Ready? Type 2 is that the HA is true and you're going to fail to reject the null. Okay. Are the consequences in question 3 or 4 more serious? People die or we just spend a ton of money? Oh, so this is going to be number 4 would be worse. Okay. And normally the health of all people is more important than money. So for number 5, the consequences of number 4 are more serious because I guess, I mean, like, we put life in more important than, money. You wanted a plague.
Yeah.
Pretty sure that's what Hitler said. Exactly. Too many. So I think this is kind of interesting when we start thinking about COVID, right? Yeah. Like thinking about COVID, how'd that go about? Right? Okay. So let's talk about it. All right. So you're going to draw this cute little box. I hate smelling faces. Oh, I need a bigger box. Okay. My awesome box of doom. Look at that. Boom. Okay. So truth. And here is, get over there. Decision. Okay. So if we have the null hypothesis is true, and if we have the alternative is true, okay, these are like kind of similar to truth tables. If you ever take philosophy in college, this is part of that class. Okay. So if the null hypothesis is true and you reject the null, okay, then you get a type 1 error. If the null, the alternative is true and you reject the null, then we Gucci. Okay. If your null hypothesis is true and you fail to reject, we Gucci. And then type 2 error occurs when your alternative hypothesis is true and you fail to reject the null. Okay. So let's put this into like words. I hate pictures. Type 1. Null is true. Rejects null. Remember, the probability of a type 1 happening is whatever your alpha is. Okay. So the null hypothesis, and you always want to make sure you write about it in context, is true, but we find convincing evidence for the alternative. Yes, I did. It's Trey. Yeah, it's Trey. So if the null hypothesis is true in context, but we find convincing evidence for the alternative. Okay. Convincing evidence. A type 2 is that the alternative is true. We fail to reject the null. Okay. So the alternative hypothesis is true in context. Why do I keep leaving a U off? Spelling true differently now. True. But we don't have convincing evidence for HA. Okay, first of all, you're yelling. It was there. Happy? First of all. All right, sorry, go ahead.
Like how the probability. Okay. So they can work to do it online and so.
I mean, we saw in the last problem, people like died because of our failure. You better have enough convincing evidence thanks, babe, to like not have a type 2 error. Like you got to make sure you're good of yourself. What's up? Type 2, the alternative is true, and we failed to reject the null. And then your description is alternative hypothesis in context is true, but we don't have convincing evidence for the alternative hypothesis. Okay. Most of the time, these questions are going to be describe the type of error that you could have. Okay. So what I'd like for you to do is go ahead and check your understanding, and then we're going to talk about it. Go. Oh, Mr. Wilcox purchased a trick coin that is supposed to land heads up 75% of the time. One of his students volunteers to test this claim. The student flips the coin 50 times and finds that the coin lands up, can't see it, 35 times. The student then performs a test to the following hypothesis at alpha is 0.1 significance level. So notice how that's different from what we had previously. Okay. The null is P equals 0.75. Alternative is less than 0.75, where P is the true proportion of tosses that the coin that would land heads up. Describe a type 1 error and a type 2 error in this setting. Okay. So type 1 and type 2. So what would be a type 1 error? Remember, type 1 is that we have the null is true, we reject the null, but we have convincing evidence for the alternative. Okay, so the coin works. So E equals 0.75. Coin works, right? Because it's a trick coin, right? Okay, but the student finds convincing evidence that coin isn't working. So that would mean that the alternative is true. So let's say that the null is 0.75. Then that would mean that the null is true, but the student finds that the coin isn't working, right? That's a type 1 error. Yes. Go ahead. So this is an error in the process. Right, because it says 0.75 of the time, right? So if this kid ran a sample and got something less than 0.75, then it's not working properly, right? So we have convincing evidence that the alternative is true.
The first couple clips landed on heads and later on too.
Right. A type 2 error, remember, is the alternative hypothesis is true. So that means that the coin doesn't work. Ooh, coin? What is that? Coin doesn't work. So P is less than 0.75. Hey, babe, come on in. But student does not find convincing evidence that coin is not working. Okay, so read that. Okay, so which type of error may result in Mr. Wilcox returning the coin and writing a negative review on the product? Which error may result in him returning the coin and writing a negative review? Type 1. Why type 1?
One, because, like, even if the coin put points on top, he didn't see that it put points on top, therefore he was.
Right. So we're saying that, hey, it works. And then a kid comes up and says, ha, no, it doesn't. Right? So that would be upsetting. He would want to return it, right? That's a little excessive, but it's okay. So he would return the coin even though it's working. Okay. Now, if the student were to use an alpha of 0.05 instead of an alpha of 0.1, would this make it more or less likely to reject the null when the null hypothesis is true? Why is it less likely? Likely? So reducing the alpha will make the type 1 error less likely. There's always a multiple choice question about this statement. Type 1.
Like less is like room for error than you do say,
Wait, we just went from 10% to 5. I'm sorry. Yeah, it went from 10% to 5%. Significance level. We're going to talk more about that. I'm trying to like introduce it slowly. I'm trying not to hit you with everything. Yeah, we're not there yet. Okay. All right. I want you to spend some time working on your 9.3 and 9.4 homework because it's due tomorrow. Okay. Girls, same. Same. So I'm giving you time now. You also have time during your pride. Okay. Or lion time. Sorry. 9.3 and 9.8.